Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create a face tracking robot with the help of esp32 camera, esp32 microcontroller, Raspberry Pi 4 and opencv face tracking module. Okay, so before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, I have started my USB camera, and as you can see, this is what the robot chassis which I have used here for this project. Okay, this is what our esp32 camera, L2910 DC motor driver board and the battery pack. Okay, and inside this top I have here esp32 microcontroller. Okay, so let me show like this way. Okay, as you can see, this is what the esp32 microcontroller, okay, which basically control our two DC motors. Okay, two DC motor. And for esp32 power, I have used here esp32 microcontroller 3V and the ground pin. Okay, so esp32 camera is basically connect with also the esp32 microcontroller for power purpose. Okay, so esp32 camera 3V and the ground volt pins which I have connect with the esp32 microcontroller 3V and the ground. Okay, so this is the chassis which I have used for this project. This chassis is basically available on the Amazon. As you can see, the Ronico double layer robotic two-wheel drive chassis. Okay, and in my opinion, this is the perfect chassis for face tracking project. Okay, because in this chassis we have here this kind of a slot, we can say the U-shape slot. Okay, so this slot is basically help us to fix our esp32 camera. Okay, so if I start the cam, as you can see how I have fixed the esp32 camera. If I make like this way, as you can see, this is what the U shape, and inside that I have fixed the esp32 camera. Okay, so because we need to track here our face, so we need to fix our esp32 camera a little bit cross, then it will track our face. Okay, so if I again make like this way, as you can see, the camera is basically not straight, it is a cross. Okay, so because we need to track our face, so we need to fix the esp32 camera, somehow we need to fix like a cross way, not straight. Okay, so that's why in my opinion this chassis is perfect, because it has this U kind of shape. Okay, also for battery I have used here this battery holder. As you can see, it has on off switch. Okay, and we can basically inside that we can set two 3.7 batteries. Okay, so as you can see, the two battery holder. Okay, so inside that, here it is, this is what our battery holder. Inside that we have two 3.7 batteries. Okay, so simple. And one more thing, this kit includes the this is the motors. Okay, the L-shaped motors, and the important things is you don't want to solder the wires. Okay, it's already soldered with black and red wires, the plus and minus wires. Okay, so if I start my USB camera again, as you can see, black and red wires. Okay, this is the two wires which I have connect with the L2910 DC motor driver board. Okay, this is basically our motors wires. So as I mentioned, the red and the black wires which already connect with the motors. Okay, so you don't want to connect the wires for these motors, this one. Okay, the L-shaped motors. Okay, so this is the advanced point. If you buy this kit, you don't want to solder the motors with wire. Okay, it's already soldered. Okay, simple. So this is the kit which I have used, as I mentioned. And as I mentioned, for battery holder I have used this cover, or this battery holder comes with on off switch. Okay, I hope you all clear. So after that, this chassis look like this way. Okay, as I mentioned, this is what our esp32 microcontroller, the battery holder, esp32 camera, L2918 DC motor driver board, and this is what as I mentioned, this is, as you can see, the L shape DC motors. Okay, so this is the chassis part. Okay, now first what we want to do, we want to install the Arduino IDE on our Raspberry Pi 4. Okay, so you can use here for Arduino IDE, you can of course use the window machine. Okay, so if you want to use the Raspberry Pi 4 machine with the Raspbian Buster legacy version, the 32-bit version, you need to install first PyApps, and then with the help of PyApps you can install Arduino IDE. Okay, so now I am going to show you how you can install the PyApps and Arduino IDE on Raspbian Buster. Okay, so friends, first what we want to do, I have created here a repository for this project, and the repository name is face tracking robot. Okay, I will mention the link. You need to first clone the repository. So open the link inside the browser, then go to the here on code, and copy the link from here, copy it. As you can see, we copy the link, open terminal, and simple as we always do, we are going to clone the repository, then we are going to change the owner. So sudo space git clone and paste the link, just hit enter, it will clone our repository. Now we need to change the owner, so sudo space chown space hyphen capital R, pi is the user and pi is the group, space our repository name, which is the face tracking robot. That's it, we have now our repository. Okay, so simple. As you can see, I have already installed the PyApps, and if I go inside the menu programming, I have already installed the Arduino IDE. Okay, so first we need to install PyApps software and then Arduino IDE software. So simple. So what we want to do, open the file manager, and we need to open our folder which we just cloned. So face tracking robot, this is what our folder. Okay, and inside that we have here install.txt text file. Right click, text editor. Okay, and just scroll down, and here it is. As you can see, install PyApps. So for that we need to simply copy this one link, copy the link, open terminal, and simply paste that link inside the terminal and just hit enter. It will automatically install the PyApps on our Raspbian Buster 32-bit version. So as you can see, it's basically installing. Okay, so friends, as you can see, it says please note that PyApps has not been freshly downloaded, already exists. Okay, so as I mentioned, I have already installed the PyApps. So we have done with PyApps installation. Now simply we need to open our PyApps, go to the menu, accessories, then PyApps. It will open the PyApps, and we need to go inside all apps, and here we have our Arduino, as you can see. So simply select the Arduino and just click it on Arduino, and it will open this kind of window. As you can see, it says uninstall because I have already installed the Arduino. Simply here you need to click on install button, and it will auto install Arduino IDE software on our Raspbian Buster legacy. Okay, so we have done with PyApps and Arduino IDE installation part. Now what we want to do, simply we need to install the esp32 board driver, or we can say we need to enable our esp32 board with our Arduino IDE software. So simply go to the menu, programming, and Arduino IDE. So friends, we have successfully opened our software. Now here we need to go inside the file, then the preferences. Okay, and simple, here we need to add our board link inside the additional board manager URL. So again we need to open our install.txt file, and here it is. As you can see, I have mentioned esp32. So this is the link for esp32 camera, also esp32 microcontroller board. Okay, so simply copy this one link, copy it, open software, and here press Ctrl plus V, victory. Okay, so Ctrl plus V from keyboard and just paste the link which we have copied from our text file. This one link, esp32, and this is the link. Okay, simple. Now simply click on OK. So go to the tools, then here boards manager. Now it will open the boards manager window. As you can see, it's opening. Okay, so friends, as you can see, the boards manager window is open, and here I have searched for esp32. Then simply click on install, and it will install the esp32 board driver. Simple. So now what we want to do, as I mentioned, we are going to use here our MQTT for creating the connection, or we can say for making the connection in between our Raspberry Pi 4 and our esp32 microcontroller. So we are going to use here our MQTT. So we need to install the pub/sub client on our Arduino IDE side. So simply go to the tools, then manage libraries, and it will open the manage library window. Okay, so friends, as you can see, library manager window is open, and I have searched here for pub/sub client. Okay, and then just hit enter, pub/sub client, and then just hit enter. Then we need to scroll down, and as you can see, the pub/sub client Nick O Larry. This is the library which we want to install on our Arduino IDE side. So simply select it and just click on install, and it will install the pub/sub client Nick O Larry library on our Arduino IDE side. That's it. So we have successfully enabled our esp32 board. Also we have installed here pub/sub client library. Okay, so now first, how we can program our esp32 camera with the help of Arduino Uno board. Okay, so for programming esp32 camera, I am going to use here our Arduino Uno board. So first I am going to explain how you can connect the Arduino Uno board with the esp32 camera for programming. Then also I am going to explain how we can connect our esp32 camera with the esp32 microcontroller, also L29A10 DC motor driver board with the esp32 microcontroller, also how we can connect the battery pack and the DC motor driver with our L29A10 and esp32 microcontroller. Okay, so first I am going to explain the hardware connectivity, then we are going to come again on our desktop machine, and then we are going to upload the sketch inside our esp32 camera. Also we are going to upload our sketch inside our esp32 microcontroller. Okay, so first we are going to see the hardware connectivity. Okay, so friends, how to connect the esp32 camera with Arduino Uno board for programming. Simple. I have here a sketch. As you can see, this is what our Uno board, and this is what our esp32 camera. Simple. So now what we want to do, the Arduino Uno 3.3 volt, as you can see, 3.3 volt pin which we want to connect with esp32 camera 3 volt. Okay, as you can see, this is what esp32 camera 3 volt, 3.3 volt. Okay, then Arduino Uno ground pin, as you can see, the ground pin, this one ground pin which we want to connect with esp32 camera ground pin. Okay, as you can see, the ground pin. So ground, connect with the ground of our esp32 camera. Then the Arduino Uno TX pin, as you can see, the green wire, TX pin, the green color wire. So TX pin which you want to connect with esp32 camera, TX pin here. As you can see, the TX, this one is the TX pin. Okay, then Arduino Uno RX pin. Okay, RX pin which you want to connect with esp32 camera, RX pin here. Okay, as you can see, the RX. So RX connect with the RX, TX connect with the TX, then 3.3 volt connect with the esp32 camera 3 volt, and the ground connect with the ground of our esp32 camera. That's it. Then we want to connect the Uno board reset pin. Here it is, as you can see, the reset pin which we want to connect with Uno ground pin. As you can see, the Uno reset connect with Uno ground pin. Simple. Then for enabling the program mode from our esp32 camera, we need to connect the GPIO 0, as you can see, the ESP32 GPIO 0, we want to connect with ESP32 ground. So GPIO 0 connect with ESP32 ground pin. Okay, so this is how you need to connect the UNO board with the ESP32 camera for programming. After complete uploading sketch process, you need to simply remove the GPIO 0 and the ground pin. Okay, so GPIO 0 and ground remove after completed uploading sketch process inside our ESP32 camera using UNO board. Simple. So this is how you need to connect the UNO board with the ESP32 camera for programming. Now we have here second sketch. So friends, this is what our second diagram. Okay, in this diagram we can see how we can connect our ESP32 camera with the ESP32 microcontroller. Also how we can connect our L29A10 DC motor driver with our ESP32 microcontroller. Also how we can connect our DC motors and the battery. Simple. So how to connect the L29A10 DC motor driver board with our ESP32 microcontroller. Simple. So L29A10, it has iron 1, iron 2, iron 3 and iron 4. Simple. Iron 1 which we want to connect with ESP32 D2 pin. As you can see, I have mentioned here pins also. So iron 1 of L29A10, iron 1 which we want to connect with ESP32 D2. So simple, iron 1, this is the iron 1 and the wire color is the green. So I have connect with D2. As you can see, the D2. If I go here perfect way, as you can see the D2. Okay, so D2 is basically pin number 2, GPIO 2. If you see here D2 GPIO 2, it's mentioned. Okay, so iron 1 connect with the D2 GPIO 2, then iron 2. Okay, the iron 2 of L29A10 DC motor driver board. So iron 2 which we want to connect with the D4. So iron 2 color is the orange. So orange wire here on ESP32 board. Okay, if I go like this way, so as you can see, iron 2 which we want to connect with the ESP32 D4, the GPIO 4 pin. Okay, simple. So iron 1 connect with the D2, iron 2 connect with the D4. So GPIO 2 and GPIO 4. Simple. Then iron 3, this one iron 3. Okay, so iron 3 which we want to connect with ESP32 board pin number 26. As you can see, the pin number 26 and GPIO 26. As you can see, D26 is basically GPIO 26. Okay, so iron 3 which we want to connect with the D26, GPIO 26. Then the iron 4 which we want to connect with ESP32 board D27. So iron 4, yellow color wire, iron 4 which we want to connect with here on ESP32 D27. So as you can see, the D27 is basically GPIO 27. So this is how we need to connect our L29A10 board pins with ESP32 as I mentioned here. Okay, so D2 iron 1, D4 iron 2, D26 iron 3, D27 with iron 4. So this is how we need to connect our L29A10 board with ESP32. Okay, simple. Now ESP32 camera. Okay, here we have the ground pin. As you can see, the ground pin which we want to connect with ESP32 microcontroller ground pin, and this is what our ESP32 camera 3.3 volt which we want to connect with ESP32 microcontroller, and this is basically ESP32 3 volt pin. Okay, so if I go like this way, as you can see, the 3 volt 3.3 volt of our ESP32 microcontroller. Simple. So this is how we need to connect the L29A10 with ESP32 microcontroller and the ESP32 camera with ESP32 microcontroller. Simple. Now how to connect the motors. So as I mentioned, we have the kit with already DC motors comes with wire solder. So simple, the red one which we want to connect here and the black one which we want to connect here. Okay, and same for here, the red one which we want to connect here, and the black one which we want to connect here. Simple. Now how to connect the battery? So battery plus means battery live connection, the red wire which we want to connect here, as you can see here, the first pin, and the battery ground which we want to connect here at inside the second pin here, second. Simple. So this is how we can power on our L29A10 motor driver board. So now how to power on our ESP32 microcontroller? Simple. So what we want to do, same pin, okay, where we connect our battery with here, as you can see the battery plus, so same pin which we want to connect with ESP32 microcontroller Win pin. As you can see, if I go like here, Win pin is basically 5 volt. So Win pin which we want to connect with L29A10 port where we connect our battery plus, as you can see the battery red wire comes here, and same the Win pin which we want to connect with the L29 board here, okay, as you can see. And then here we have the ground pin. If I go here, ground pin, as you can see the ground pin which we want to connect with L29A10 board here, as you can see. So Win goes here, ground goes here. Simple. So this is how you can power your ESP32 microcontroller using L29A10 DC motor driver board. I hope you clear how we can connect the camera with microcontroller, the L29A10 with the microcontroller, also how we can connect the DC motor with the L29A10, also how we can connect the battery pack with L29A10 DC motor driver board. Okay, so now we are going to simply upload our sketch inside our camera, and then we are going to upload our motor sketch inside our microcontroller, ESP32 microcontroller. Okay, so friends, we have successfully connect our Arduino Uno board with our ESP32 camera. Now simply we want to upload our sketch inside our ESP32 camera. For that, simply open the file manager, go to again the folder which we have cloned, face tracking robot, simply open it, and inside that you can see ESP32 cam main.zip. This is the zip file. Okay, so you need to simply unzip the file. So right click and just click on extract here. As you can see, click on extract here and it will extract our folder. As you can see, we have now our folder. Now what we want to do, we want to simply open our Arduino IDE software. So go to the programming, Arduino IDE. Now it's opening our Arduino IDE software. Okay, so friends, we have opened our Arduino IDE software. Now go to the sketch, then click on include library. As you can see, click on include library, and here we need to select the add zip library. So select it, add zip library, and then you can see this kind of window. Okay, and here we need to select our folder which we clone. So our folder name is face tracking robot. As you can see, face tracking robot, select it, and inside that we have our ESP32 cam -main.zip file. Simply click on OK, just select it and click on OK. Now we have successfully upload the library. Okay, so if you open the file manager, and this was our Arduino folder, go inside the Arduino, go inside libraries. As you can see, ESP32 cam main, this is what the library which we just installed. Okay, now we are ready. Now what we want to do, simply close the software, close it, and what we want to do, again go to the home here, click on home, and then again go to the Arduino, then libraries, then ESP32 cam main folder, then examples folder, then Wi-Fi cam folder, and this is what our sketch for Wi-Fi cam, the ESP32 cam. So simply right click, click on open, and it will automatically open the sketch from our Arduino IDE software. So as you can see, it's basically opening the sketch. Okay, so friends, as you can see, we have opened our sketch, and here you need to mention your router SSID. So simply mention your router SSID, and here you need to mention your router password. Okay, so as you can see, I have mentioned the router SSID, mine router SSID, and the router password. That's it. Now there is nothing to change. You need to simply go here, tools. Okay, then the board, we need to select our ESP32 camera board. So ESP32 Arduino, and here we are going to select ESP32 rover module. As you can see, ESP32 rover module. So simply select it, ESP32 rover module. Then again go to the tools, upload speed 115200, select it. Then again go to the tools. Okay, then here we need to select huge app. Let me go here again, just a minute. Again go to the tools, and here we need to select huge app. Okay, and then again go to the tools, and from port we are going to select the Arduino Uno. Okay, so I am going to connect our Arduino Uno board. Okay, so friends, I have connected the Arduino Uno board. Now if I go inside the tools and in port, as you can see, /dev/tty acm0 Arduino Uno. So selected the Arduino Uno board because we are using here our Arduino Uno to program our ESP32 camera. Okay, so simply select the Arduino Uno board. That's it. Now we have successfully select our tools. Again, I am going to explain here. Select the ESP32 Arduino, then select the rover module, then upload speed 115200, then the partition scheme which we want to select, huge app, then the port we want to select /dev/tty acm0. That's it. We have mentioned here our router SSID and password. Now we are ready. Now we need to simply upload the sketch. So simply click on upload, and now it's uploading the sketch. Okay, so friends, as you can see, we have successfully uploaded our sketch inside our ESP32 camera using Uno board. Okay, so as you can see, this is what our Arduino Uno board, which I have connected with ESP32 camera as I mentioned in the diagram. Okay, now what we want to do, we have successfully upload our sketch. So we need to simply remove this jumper cable, the yellow one. As you can see, the yellow jumper cable which basically connect with the ESP32 GPIO 0 and the ground. We connect this jumper cable for programming mode. So now we have successfully upload our sketch. Now we want to remove this jumper cable. Okay, so yellow jumper cable, so I am going to remove it. Okay, so friends, as you can see, as I mentioned, the yellow jumper cable, so I am going to remove it like this way. So as you can see, I have removed the yellow jumper cable. Okay, and then what we want to do, as you can see, we have here a reset button, this one. We have here a reset button, so we want to simply press the reset button. Now we can simply open our terminal from Arduino IDE side. Okay, we need to go here and we need to open our serial monitor. As you can see, /dev/tty acm0. Okay, so now again I am going to press the reset button from our camera, and then we will see here the message like this way, and we can see the IP address. As you can see, HTTP 192.168.0.106. So this is what our IP address for ESP32 camera. Okay, so we have successfully uploaded the sketch inside our ESP32 camera. Also our ESP32 camera is successfully received the IP address from our router. Okay, now we are going to upload the sketch inside our ESP32 microcontroller for controlling the DC motors. Okay, so friends, we have done with the ESP32 camera side. Now we are going to move on our ESP32 microcontroller side. So we need to upload our sketch inside our ESP32 microcontroller board. Okay, so simply connect the ESP32 microcontroller with the Raspberry Pi 4 using normal USB data cable. Okay, so friends, as you can see, I have connected the USB data cable with the ESP32 microcontroller. Okay, as you can see, this is what our ESP32 microcontroller, and this is what our USB data cable. Okay, now here it is. As you can see, we have here a blue color jumper cable. Okay, so this jumper cable I have removed it from our ESP32 win pin. So win pin, which I have already explained, win pin is basically a power on our ESP32 microcontroller using our battery pack. So when you program your ESP32 microcontroller, remember one thing, you need to remove the win pin. As you can see, I have removed the jumper cable from the win pin of our ESP32 camera. Otherwise, it will overcharge our ESP32 microcontroller. So remember one thing, when you install or when you uploading the sketch, you need to remove the jumper cable from win pin of our ESP32 camera. You need to only connect the USB data cable with the ESP32 microcontroller. Simple. Now we are going to move on our desktop. Okay. So friends, now what we want to do, we want to again open our face tracking robot folder. Okay. So as you can see, I have already opened. So this is what our folder inside /home/pi. Okay, face tracking robot, and here we have motoface.ino sketch. This sketch is basically for controlling the motors, the DC motors, with the help of ESP32 microcontroller using MQTT. Okay, so simply we need to copy the sketch, copy it from the face tracking robot folder and go to the home, go to the Arduino. Then here, as you can see here, we need to simply paste that sketch. So simply paste it. Okay, as you can see, I have pasted the sketch. Now simply from here we need to right click and click on open. It will auto open the sketch. Okay, so as you can see, it's opening. So friends, here the file motoface.ino needs to be inside a sketch folder named motoface. So simply we need to click on OK, and it will automatically create the folder and it will move our motoface file inside the motoface folder. That's it, simple. So here what we want to do, as you can see, the wi-fi.h pubsub client library which we have already installed, and this is the pins. Okay, IN1, this is the L29A10 DC motor driver pins, and this is what our ESP32 microcontroller pins, which I have already explained. So IN1 connect with the GPIO2, IN2 connect with the GPIO4 of our ESP32 microcontroller, then IN3 of L29A10 DC motor driver board, which we want to connect with the ESP32 microcontroller GPIO pin number 26, and IN4 which we want to connect with the ESP32 microcontroller GPIO 27, as we already seen in our picture. Okay, or we can say this diagram. Simple. Then here of course we need to mention the router SSID and the router password. Simple. Then the MQTT server. So this time we are not going to use a free MQTT server. We are going to create our Raspberry Pi 4 as a MQTT server. So we need to mention here our Raspberry Pi 4 IP address. So you need to simply open the Raspberry Pi 4 terminal, and let me clear the screen, and here we are going to run the command ifconfig, and then you will get the Wi-Fi address, or you can get the ETS0 address. Of course, because I have connected the Raspberry Pi 4 with Ethernet also the WLAN. So you can use either ETS0 IP address, or you can use simply WLAN 0 IP address. So I have mentioned here my Wi-Fi address. As you can see, the Wi-Fi address is right now 192.168.0.103. So you need to mention the IP address. Okay, so 192.168.0.103. in my case, this is what my Raspberry Pi 4 WLAN IP address. Simply so mention the IP address. Then there is nothing to change. I have already set perfectly. Okay, all these things are perfect. You need to simply mention the router SSID, password, and the Raspberry Pi 4 IP address. Simple. Now we are ready, and because we already enable our ESP32 board, so we need to simply go inside the tools, and this time we are going to select again ESP32 Arduino, and we need to select a dev kit module. Okay, so we are going to search for do it dev kit. Okay, so as you can see, do it ESP32 dev kit version 1. So select it, do it ESP32 dev kit version. Again go to tools, do it. As we select our board, then the upload speed 115200. Then again go to the tools, then port which we want to select /dev/tty USB 0. This is the port where we connect our ESP32 microcontroller. So select it, simple. Now we are all done with the setting part. Now simply we are ready and we are going to upload our sketch. So simply click on upload, and now it's uploading the sketch. Okay. So friends, as you can see, our sketch is uploading inside our ESP32 microcontroller, as you can see. So friends, we have successfully uploaded our sketch, as you can see, 100% done. So it means we have now done with our ESP32 camera side. Also we have successfully uploaded our sketch inside ESP32 microcontroller. Now simply connect the ESP32 camera, L2910 DC motor driver board, also connect the battery with the L2910 as I mentioned in the diagram. Okay, so now we have done with ESP32 side. Okay, now we are going to move on our Raspberry Pi 4 side. So simply now we are going to see on Raspberry Pi 4 side. Okay, so friends, now we are going to see our Raspberry Pi 4 side. So simply first we need to open our repository face tracking robot, and inside that we need to again open our text file. So open the text editor, install.txt. So as I mentioned, we are going to create here our Raspberry Pi 4 as a Mosquito broker server. So for that we need to run some commands. So first one, we need to install your Mosquito clients package. So copy the command, open terminal, paste the command and just hit enter. It will install the Mosquito and Mosquito-clients on our Raspberry Pi 4. Then simply we are going to enable the service. So copy the second command, open terminal, paste command and just hit enter. That's it. Now we need to open, or we can say we need to edit the mosquito.conf file, and inside that we need to paste these two lines at the end. So we are going to use here a nano editor. Again, you can use any editor. So this is the command for nano editor. Copy the command, open terminal, paste and just hit enter. It will open the file, and as you can see at the end I have copy and paste these two lines, listener 1883 and allow anonymous true. Simple. Press Ctrl X, Y and enter the button and just save the file. Simply. Now again we need to start our service. So copy it, command, paste inside the terminal and just restart the service. Now simple, we need to test our server. So we are going to run our server at the back end. So for that we need to run this one command, mosquito space -d. It will run our server at the back end. So paste, just hit enter. Now we need here another terminal. So we have now our two terminal, edit, zoom in, zoom in. So we have here our two terminals. So this one we can say is basically the publisher, and this one we can say is the subscriber. So this is the subscriber command, mosquito sub, copy it, and this one is our subscriber terminal. Paste the terminal, not terminal, paste the command inside the terminal and just hit enter. Okay, so it's basically waiting. It's subscribed with the topic, the test topic, and now it's waiting for the message. So now our second terminal, and here I am going to copy and paste our command, which is the publisher side command. Okay, so as you can see, test topic is the topic and we are going to publish the hello world message. So simply hit enter. So we have successfully uploaded the message. Now if I open the terminal, and here we have our message, it means we have successfully received the message. It means our server is perfectly working. So simply press the Ctrl C and we are ready. As I've already mentioned, we have mentioned the Raspberry Pi 4 IP address already inside our Arduino side. Okay, 192.168.0.103. Simple. So we have done with Raspberry Pi 4 package installation side. Now simply first what we want to do, we want to open, go to the programming, Tony Python IDE. Okay, and go to the file, click on open, and our folder, which is the face tracking robot, and inside that we have esp32 tst.py. Okay, and here as you can see, this is what our esp32 camera IP address. So what we want to do, open the browser and we need to open here our esp32 camera address. Okay, so 192.168.0.106. Before we start our browser, we are going to test if we can ping with our ESP32 camera address, because as I mentioned, I have connect the ESP32 camera, then ESP32 microcontroller, the L2918 DC motor driver with the battery pack. Okay, so now if I try to ping 192.168.0.106, this is what our ESP32 camera address. As you can see, we have successfully pinged with ESP32 camera. It means our hardware is perfectly connected. Okay, so now simply if I open here again 192.168.0.106, just hit enter, it will open this kind of window, as you can see. And here we need to select 800, 600, and then we can get the photo. As you can see, this is what the live photo. It means we have successfully enabled our camera and we are capturing the images. Okay, so simple. I have to again enter here the IP address because I have forget to explain here. So 192.168.0.106, this is what our IP address. Select the 800 to 600 and this is the link. This link, in your case of course the IP address will be different. Okay, so copy the link, copy it, open Thony editor, and inside that esp32 tst.py, the link which we have copied from the browser, simply paste inside here the URL. As you can see, I have pasted it. http:// as it is. Okay, http:// IP address, then 800 into 600.jpg. So copy and paste the link inside the esp32 tst.py file. Okay, then we can able to access our ESP32 camera inside our opencv, means inside our main face recognition program. Okay, simple. Now we need to simply open our main script. So go to the file, click on open, and face.py, click on OK. As you can see, we have successfully opened our main script. So import CV2, mediapipe SMP, power MQTT, then time, then ESP32 TST. So ESP32 is basically our script where we create our cam function. So from ESP32 TST, we need to import our cam function. Okay, then the basics script for capturing the face with the help of mediapipe. I have already explained all these things. Okay, so I'm not going to explain all these things again, how we can track the face with the help of mediapipe. Okay, simple. Then this is what our function for sending the message with the help of publisher. So basically Raspberry Pi 4 is our publisher and ESP32 microcontroller is basically our subscriber. So stop function, and here it is. As you can see, this is what our server means, that this is what our Raspberry Pi 4 IP address, same address which we mentioned inside our Arduino side. So 192.168.0.103, and the client Raspberry Pi 4 0, then client.connect MQTT broker. This is the MQTT broker variable, is basically represent our Raspberry Pi 4 IP address. Then client.publish, this is the topic test2, and this is the message which we want to send, the stop message. Okay, then same way for turn, then turn 1, then back, and then the forward message. Simple. Then this is the object data function for tracking the face. Simple. Convert with the BGR to RGB image, then we are going to process the image, then it will detect the face, then bounding box, then XYWH, then we have rectangle, then the center points, then the CV2 circle. Okay, simple. This is how we are going to detect basically the face, and we are going to detect the face center points. Simple. So now what I am going to do, I am going to start the camera and I am going to explain all the things step by steps. Okay, so friends, as you can see, I have started the ESP32 camera. Okay, as you can see, it's tracking my face. If I go like this way, as you can see, it's tracking my face. There is a rectangle, we have rectangle. Okay, so now I am going to explain how we can create the left, right and forward action with the help of our center points. Okay, So friends, first I need to explain here one more thing. We are going to use here our cx and cy. Okay, so cx and cy, with the help of cx and cy, we can simply draw the center point on our face. Okay, means this is the center point of our face. Simple. And then with the help of cx and cy, we want here a and b. So a is equal to int and the cx, this cx divided by 62, and then we are going to put the a on our frame at right side. Means when we start our frame, we will see the numbers, the range on our right side. Okay, and that range will basically represent our a. Okay, on right side. Then the b is equal to int cy, this cy minus h, this h divided by 10, and this b I am going to put on the frame on left side. So on the left side we will see the range represent basically the b, and the right side on the frame the range which basically represent our a. So a range we are going to use for creating the left and right action, and the b range we are going to use for creating the forward action. Okay, simple. Now simply I am going to start our camera. So friends, as you can see, we have started our esp32 camera, and as I mentioned, first we are going to see right side range which basically represent our a for creating the right and left action. So as you can see, the right now my face is at center, we can say, and the range is 5. Okay, the 5. So if I go right, it's now increasing, the range is now 7, 8. If I again come at the center, it's now 5. If I move left, 4, 3, 2, 1, as you can see, again here right, 7, 8, again left, it's less than 4, 3, 2, 1. If I come at the center, it's 5. So simply we can say, if we want to move our robot right side, so we can say if the range is greater than 6, as you can see, it's now 7, 8. If the range is greater than 6, our robot will be moved at the right. If the range is less than 4, as you can see, it's 4, 3, 2, 1. Now we want to move our robot at the left. So we can simply create the if condition. If the range is less than 4, the action will be, or we can say our Raspberry Pi 4 basically send a message to turn, means to turn the left side. Okay, as you can see, the range is less than 4, again 5, range is greater than 6. Simple. So this is how we can create the left and right side range with the help of a point. Now we are going to see the b point, which basically we put on our frame left side. Okay, so right now as you can see, the range is 9. So if I go back, as you can see, the range is increasing, is now 20, 21, 22. At the left side, as you can see, at the left side is increasing 24. So we can simply say, here it is, as you can see, we can say if the range is greater than 12, if the b is greater than 12, our robot will be moved forward. Okay, else stop. Else we can create a stop action. Means if the range is greater than 12, the robot will be moved forward, else it will stop. Okay, means else the range will be less than 12, of course the robot will be stopped. Simple. So this is how we can simply create the forward, left, right action with the help of center point of our face. Simple. Now we are going to simply see the if conditions. So friends, as you can see, I have mentioned if condition. If b, for creating the forward action, if b is greater than 12, the action will be forward, and the forward action is basically, here we have created the function. So forward function which basically send the forward message with the help of MQTT on our esp32, and our DC motor will be create the forward action, means our robot will be moved forward. Okay, and then else the stop, means else the range is less than 20 and the function will be called stop. Our stop function, as you can see, our stop function is basically send a stop message and our motor will be stop. Simple. So same way as I already mentioned, if a is greater than 6, it will move the right. So turn 1 function, turn 1, this is the turn 1 function, is basically send a message on esp32 to move right. Okay, so it will send the turn 1 function and the motor will be create the right side action. Simple. Now after that we have, if a is less than 4, then it will create the left action and it will call the turn function. Okay, and the turn function basically send the turn message and it will create the left side action. Simple. And here we need to create a clockwise rhythm action, means tick tick tick, we can say tick tick tick. So we need to create here a time dot slip for 0.1, then turn 1 function, then again time dot slip 0.1, then stop function. If we call our turn 1 function without slip or without stop, it will continuously move turn. Means when you create the greater than 6 action, it will continuously move right side. Okay, so we don't want that type action. We want to move slowly, because when we move, it need a next point, it need our face next point. So we need to create a clockwise action, the clockwise rhythm action. So for that I have mentioned here time dot slip 0.1, then turn 1 function, then again time dot slip, then it will stop, and this will happen again and again because we have here our while loop. So same thing for a less than 4, time dot slip 0.1, turn 1, not sorry, turn 1, only turn, and then time dot slip, then again stop. Simple. This is how we can create the forward and left right action with the help of opencv and mediapipe phase tracking module. Now we have all the done with software side, hardware side, installation side. Now we are going to ready for live action. Now I'm going to start the camera and we are going to see the live action. Okay, so friends, now we are going to see the live action. So if I move right, as you can see, the robot is also moving right. It's basically tracking my face. Okay, so if I go left, as you can see, it's coming and left. Okay, so if I move back, as you can see, it's coming forward and it will stop. Again, the left, 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 left. Okay, if I go right, show the face perfectly. Okay, as you see, it's coming right. Okay, so this is how we can create a face tracking robot with the help of opencv and mediapipe face tracking method. I hope you will learn something from this video. We will meet on next video. Till then, thank you.